Okay guys, so in the next question, in question 70 and 22, express each of these in the regular form a plus bi. So guys, it's just literally of multiplying these out. So it's going to be root 2 multiplied by cos 45. Just make sure cos 45 is on the outside. And what we get here is 1. So this changes into 1 plus, and then you're going to multiply it by sine 45 this time. So just leave it as sine 45. So it is pretty much as easy as that. So it's 1. So we're going to get 1 plus 1i for question 18. So question 18 is 1 plus i. Question 19. Now in question 19, what I tend to do is I tend to change pi equals 180 degrees. So it's 2/3 of 180 degrees. So 2/3 of 180 is 120. So you can do 120, 120. Okay, 120 degrees. Or you can put it in radians mode in your calculator, wherever you want. So I'm going to go say 6 cos 120, because it's going to be 6 multiplied by cos 120, and that gets me minus 3. And then it's going to be 6 times sine 120. So just go back here and change the sign. And what we get here is 3 root 3 plus 3 root 3. So it's going to be 3 root 3, and don't forget the I for the sine part, minus 3 plus plus 3 root 3. Okay, so let's try another one out. What about number 22 for example? In number 22 we have 2 root 2 cos 315, so 2 root 2 cos 315. What we get here is 2. And then the next one is going to be 2 root 2 sine 135. Change to sine 135. And then what we get here is minus 2. So 2 minus 2i, and that's the answer for number 22. Minus 2i. Okay, so that's 18, 19 and 22 done. Now let's look at 24. Let u equal root 3 plus I and w equals minus 1 plus root 3i. So that the argument of u plus the argument of w equals the argument of u multiplied by w. Now, once again, what is the argument? The argument is the angle. Okay, so what we got to do is get the angle. Okay, so what we can see here is that root 3 plus I is going to be root 3 across and I up, which is 1 up, because it's 1i. Now we have to find out the angle theta. Tan theta equals 1 over root 3, tan inverse that, and we get 30 degrees. Okay. On the next one, it's minus 1, which is left 1 up root 3. So it's a much bit more of a steeper angle this time. Okay, so what we have this time is 1 across root 3 up. So we'll call this x. So tan x, still the argument is root 3 over 1, and that equals 60 degrees. Now the problem is with this one is that that's 60 degrees, but we got to remember it's the full angle we're looking for, so technically this is the reference angle. So it's going to be 180 minus 60, which is going to give us 120, tan 120 degrees. Now, what it wants us to do now is that it wants us to show that the argument of u plus the argument of w equals the argument of u multiplied by w. So we're going to have to multiply u by w first. U by w is root 3 plus I, and then it's going to be minus 1 plus root 3i. We're going to multiply that out, and what we're going to get is minus root 3 plus 3i minus I plus root 3i squared, and that's going to be minus root 3. So it's going to be minus 2 root 3, and then that's going to be plus 2i. Now this is a new complex number we have here, and this new complex number, we're going to figure out where it belongs on this ladder. So it's going to be minus 2 root 3, which is here, and then plus 2, which is up here. So we're talking about an angle here. And then we're going to have figure out the reference angle. The reference angle is going to be 2 root 3 on the bottom, 2 on top. So it's going to be, or in this case, is going to be tan inverse 2 divided by 2 root 3, which is going to get us 30 degrees. This 30 degrees has to be taken away from 180 because it's the second quadrant. So quadrant 2 is 180 minus your reference number, or your reference angle, which is 30, and that equals 150 degrees. So what we had here was the argument of u is 120 degrees, the argument of w is 30 degrees, and that equals the argument of uw, which is 150 degrees, hence it's true. Okay, so 26. Once again, I'm just going to convert all of these back into degrees. Okay, so anytime I see pi, I'm going to replace it with 180 degrees. So they're all speaking the same language. Okay, so it's going to be 3/4 of 180. So that's going to be 135. So this angle here is 135 degrees, and the last one, which is 7/6 of 180. So just come in here and change this around. 6, and then that can be 7. And then that one there is going to be 210. So 210 degrees, okay? So it says find A. Okay, so Z1 is A plus 8i. Now we know it makes a 135 degree angle, which means that it's going to be in this quadrant here. And what we know is that this angle here is going to be 8 up and A across. A has to be a negative number because it's going backwards, okay? It's in the second quadrant. So what we also know is that this here is 135, which makes this 45. So tan 45 equals 8 over A equals 8 over tan 45, A equals 8. Now that's 8 here, which is technically a minus 8 because it's going to the left. So A therefore is going to be equal to minus 8. Okay? Because it's going to the left. Now, what is the modulus of Z1? Well, the modulus of Z1 is now minus 8 plus 8i. Modulus of Z1 therefore is the square root of the real number, which is minus 8 squared, plus the imaginary number, which is 8 squared. Put it into the calculator, and we find out that the modulus is going to be 8 root 2. So I think it's going to be the square root of 12a, which is in fact 8 root 2. Okay, now find out what B is. Okay, so in this, once again, we have B, Z2 has an argument of 225 degrees. 225 degrees lands you in the third quadrant, and it lands you 45 degrees up, because that's 180 here, and then 225 is all the way out here, which is the extra 45 degrees. Now what it says is that it's going to be minus 3, so minus 3 across, which is the same thing as 3 here, and then we're going to have B down, and B is going to be a negative number. Just to let you know, wherever we get, it has to be negative to go downwards. Okay, so what we're going to get here is we're going to get tan 45 equals B over 3. B equals 3 tan 45. B equals 3. Now because it's going downwards, since in the third quadrant, B has to equal minus 3 because it's going downwards. So this complex number b is therefore minus 3. And now we have to find out what the modulus of this is. So the modulus of Z2 is minus 3 minus 3i. The modulus of Z2 therefore is going to be the square root of minus 3 squared plus minus 3 squared, which is going to get me 3 root 2. Okay, now we're on part C, part 3. Now this one here has an angle of 210 degrees. Once again, it's in the third quadrant and it's down 30 degrees. Both the C and minus 1 are negative, so it's going to be minus 1i, which is down 1, which is 1 down. C across. Now remember, they're both going to be negative, so it's going to be Z3 is going to be minus some number, and then it's going to be minus I, or minus 1i. So to figure out this, we're going to say that tan 30 is equal to 1 over C. C therefore, when you bring the C up and the tan 30 down, it's going to be 1 over tan 30. So 1 divided by tan 30. And what we get here is root 3. So C equals root 3. But please remember, it's root 3 to the left, so it's minus root 3. Okay? So C is minus root 3. The modulus of Z3 therefore is going to be the square root of minus root 3 squared plus minus 1 squared. And what that's going to get me is 2. The modulus of Z3 is 2. And that's minus root 3. Now, finally the last one is 300 degrees. So 300 degrees will leave me this far in, and we're talking 60 degrees away from the end, because a full rotation is 360 all the way across. Okay, and what we have here is we stop 60 degrees short because we're at 300, and from 300 to 360 we're talking about a 60 degree rotation here. Okay, so 60 degree rotation. Now, put in our numbers. D has to be a negative number because it's below the axis, okay? So Z4 is going to be 2 root 3 minus some negative number times I. So what we have here is 2 root 3 on the real axis, and we call it D on the y axis, so we say tan 60 equals D over 2 root 3. D equals 2 root 3 tan 60. And what that's going to get me, my calculator, is that D equals 6. Now it's minus 6 because it's 6 down, so it's going to be minus 6 here. Okay, so D equals minus 6. Next thing you have to do is get the modulus. So Z4 ends up to the modulus of 2 root 3 squared plus minus 6 squared. Put that into the calculator and we find out that Z4 is going to equal 4 root 3. The modulus of Z4 equals 4 root 3.